Before we go into the big UI changes, let's go over some of the networking level changes in the code. In order to encapsulate the new ride JSON object from the server, I added an equivalent properties object locally. The class is practically identical to the server-side ride_DAO class, but uses the properties syntax instead of the standard POJO syntax. The driver service class is a static representation of the driver-specific server API. This field represents the ID of the current ride from this driver. Here we have the standard get method I mentioned earlier to retrieve the ride details and return them via a callback. We use accept to indicate a driver is accepting a user's hailing. If he doesn't, we don't care. Once accepted, he gets a reference to the ID of the newly created ride object in the server. Notice that failure is indeed a possibility. For example, if the user cancelled the ride or a different driver accepted first. When we invoke start ride and finish ride, we use current ride ID, unlike the user ID which we used to create the ride. In search service, we had to add support for geocoding. Before this, we only had the reverse geocoding, which we used to locate the from/to points on the map. We need this API since the driver only gets the to/from location names, and we want to plot them on the map. There isn't all that much to say about this method. It just searches the Google Geocode API for a location with the given name and returns the coordinates of that location. There were many small changes in the user service class. Most of them relate to the way identity is managed in the app. One of the big problems in having two applications with one project is that both projects share the same data in the simulator. So if I want to launch the project twice, once to run the user version and once for the driver version, I will have a problem. Both will inspect the same storage information and use the same user identity. They might collide. Notice that this is purely a simulator problem. The simulator doesn't currently isolate separate applications. Ideally, this is something to improve in the simulator and might not be an issue in the future. The solution is simple though. We can just save the data to different locations or keys. If we are in the driver app, let's review the changes. This is illustrated perfectly in the first change in this class. We use a different token to determine if the user is logged in for the case of a driver. Notice we replaced the invocations of preferences.getToken that were all over the code with this method call. The preferences bind API lets us set a different prefix for the driver object that will be prepended to the properties in the preferences. This is a cool little trick that allows me to debug with a fake number. I used the isSimulator method to log the verification code on the simulator and can just type it in even if the Twilio code failed to send a message. Sends the push notification token to the server. Right now, we don't need to do anything in the event callback. This is invoked on registration success and allows the server to send driver push keys to the client. After the first activation of the driver app, we need to register for push. Notice I'm using the version of this method from the CN class with static import, but the callback will go as expected into the driver app class.